Thank you again, guys, for joining in. Today we are talking about end-to-end ML. It's part 3 of our session, and when we started the discussion, we talked about how is this a 6-step process, right? So we said we'll start by talking about the process, which we talked about. We can revisit that discussion when we do the demo. We talked about how there should be multiple phases, starting with first onboard and do a POC and then do an MVP and then do your industrialization. Do not go about implementing an MVP project right off the bat, because then you will be stuck in that cycle and the project is never going to get into an industrialization phase, right? So have tangible targets, have a scope of POC, and we talked about those, right? Then we said typically, once the process is established, uh, what is that maturity? How do we know what clients have versus they do not have? We talked about 5-step maturity index, right? We said there is a framework where we can now evaluate the maturity of the clients. We talked about tier 0 to tier 4, if you remember. Then we had a good discussion last time around platform setup. And we said it is important to have access to production data in most of the cases. And the production data access should be done through a specialized sort of a sandbox, and we called it production playground. So that discussion, we talked about some of the edge cases where people from multiple backgrounds, life sciences, they talked about what it means not to have that kind of a production access. And we said, well, it might mean to have a similar kind of a production playground in dev, in QA, which means now it is the client's responsibility or Accenture's responsibility to ensure the right kind of data available in all the 3 platforms, right? So we understand all the challenges that comes with it. We started the implementation process. We had a very detailed implementation process talking about how the data onboarding works, what is that POC process looks like, and all that stuff. So today we're going to start from the other side of the implementation process, and we'll try to focus on the users and personas, and then we'll talk about the ops part, and then we'll see that how all of this can come together within an asset. So we have an asset that we have started creating. The asset is on Databricks, but we'll see how IDF and the Databricks specific asset today can help us tie up these processes together, at least technically. So again, this is the same view that we talked about last time. There is a 10-step model deployment process. If you can build an asset that has these 10 capabilities, the 10 modules, then I think it will help our clients accelerate mostly. So step 1, data and feature engineering pipeline. So ability to extract data, do pre-processing, perform data quality check, do feature engineering, and save the data into something like a feature store. So once you have that, then you start with your actual model building, which is start the experimentation, evaluate your models, evaluate model against the other model, do champion challenger, do shadow testing. Then you have matrices, parameters, and model logging. So mostly catalog the model information and put the model into a model registry. So all the model and the model metadata goes into the model registry as a model metadata. And then you talk about serving the model. You serve the model by providing access to the prediction capability through either batch or real time. You do model validation in production. You package the model for lower environment to higher environment, and you serve the model. And once you serve the model, you continuously monitor the model, monitor the incoming data against the baseline data, and evaluate whether there is any drift in the model in the data. And from the orchestration and governance perspective, we talk about the pipelines, check in, check out your code for the pipelines, workflow orchestration to ensure that your machine learning training processes are orchestrated with your data pipelines, so that once the data is loaded, new features are created, you retrain the model through a pipeline. You should talk about continuous integration and continuous training, the CI/CD process, and end-to-end data quality and model quality matrices. So any drift in the data, so observability of the data, checking whether the model is evaluating and performing correctly, what is the quality of the outcome of the model, by continuously evaluating the outcome of the model against the new ground truth. So if you design all of these as modules and stack them together, it creates an end-to-end ML view technically. Right? So question now is, we have last 2 sessions talked about what is needed and what are the driving principles and what are the capabilities. Question is, everybody can design something like that, but from an Accenture point of view, what is the differentiator? What we're trying to bring to our clients? So we're saying that, hey, why not we design a framework or an accelerator? But the question is why? So again, I've tried to list down some of these examples, but again, there might be more or less. So question number 1, quick innovations, right? So we should not focus a lot of time in building these engineering components, exploratory data analysis, access to the production data, doing model scoring, saving the model into a feature, saving the parameters into a feature store, accessing data from a feature store, scoring the model, registering the model outcome into a model registry, cataloging the model. So there is a lot of engineering heavy work that we can actually offload. We can make it as a part of a very simple SDK or something very simple that can be incorporated as a part of the process. Second thing is very similar to data pipelines. If you ask data scientists to go and build their own models, everybody will have their own preferred way of building models. And again, things change over time. So ML models, the pipeline that creates the model, trains the model, and eventually predicts the model, those pipelines, you'll have n number of those pipelines in production. If you do not have a common standard workflow and process through a framework, you'll end up seeing that from a maintainability point of view, every model is different. Every model has different ways of measuring things. Every model is doing things in a different way. So again, we want to standardize, give the run and support, give the hypercare team a much more tangible way of managing the outcomes. Same, we talked about the repeatable and common attributes. So talking about, it's a very modular approach. You can plug in the modules, you can use the modules. So you can use modules for feature extraction, you can use modules for data extraction and so forth, right? So all of that can be done through the SDK or the framework. Repeatable and measurable deployment. So again, things which have gone through a process, is a framework, it's very easy to package those outcomes. You don't have to reinvent the wheels all the time. And again, same thing, predictable outcomes. You know what you're going to get. So all of these are reasons why we are thinking about all these steps that we talked about till today can be converted into an accelerator. So again, when we talked about it, what this accelerator would look like and what this asset would provide. So why, again, apart from why we need an accelerator, the point is, in today's world, we talk about databricks, we talk about SageMakers, but in all honesty, majority of data science is not through SageMakers or Databricks. It is through these 50,000 Python packages that people have been learning or using for ages. So question is, who can tap into this open source platform the best? So you cannot just say, hey, I have a Databricks as a platform and that is enough. Databricks on its own might not justify and suffice. You need to bring in all these 50,000 packages, incorporate those and bring them into a tangible way, right? Consumable way. Same thing, non-standard. If you do not have an asset, everything will be non-standard. Everybody will do their own way. There are different possibilities I talked about. Same thing, lack of big picture, right? So we talked about users, we talked about access control, we talked about personas, we talked about processes. Just by providing SageMaker as a service or Databricks as a service, we may or may not be able to understand the bigger picture, like who or else are involved. How do we design a solution where everything is easy? How can a data scientist team build a project and hand it over to an ML engineering team and so forth, right? So with all that said and done, we are saying, like, let's build out an asset. The asset will have a lot of characteristics. One, it'll come with these bells and whistles, which means, all the things around data drift detection, biasness, fairness, stability of the data, all of these will be pluggable, modules, so that I'm not spending cycles designing and building how to track and how to detect drift in my data or fairness in my outcomes. Similarly, we talked about centralized extensibility. So again, we have understood and identified best of breed packages, saying what kind of packages are needed for exploratory analysis versus what kind of packages are best suited for time series AutoML analysis. So we have gone through that extent and already have come up with this extended integration between something like a Databricks and these third-party packages for doing certain capabilities, like for doing EDAs, We have identified 5 packages. We have done the integration so that when you onboard your data, you can analyze data visually and statistically easily. Save money. Again, Jumpstart Kit is intended to provide 30-40% acceleration to projects. That way we can deliver the project faster, so it is more reassured that the outcome will be much more risk-free, right? So you have a framework, and if you have gone through the framework, if the framework is vetted enough, then it gives you that confidence that things that are designed through that will have less bugs. Similarly, persona-based framework, so the same framework can be used by data scientists, but eventually the same framework can be used also by ML engineers when the data science team has given them the projects or the code. And similarly, we talk about repeatability and reusability. So using the SDK, we not only build one model, but we can build similar models day in, day out, right? So these are the rationales of why we are going towards building an asset. Now, what this asset should have, again, this is a slide we have seen many a time, and this is where we are tying back our IDF story to the ML story. So I'm not going to boil this slide. We have talked about this slide long enough. So same thing, right? So somebody says, oh, I need to bring in product data and order data from SFTP and RDBMS respectively, and my intention is to do a forecasting model. I want to understand which products are ordered more on a week-to-week basis, right? So I want to build a forecasting model. So in that case, the intention is to onboard the data. So data availability is important. So we build a pipeline where we can bring the data to raw, apply rules engine, data quality engine, STM, reconciliation, data consolidation, MDM, data curation, and then put everything into a centralized metadata repository, right? So we do steps 1 to 10 for one source, and we do steps 1 to 10 again for another source, and then we go into our IDF ETL transformation engine, and through a visual drag and drop way, we build complex business logic to create a data mart, and then publish the data mart as a feature store, so that becomes the basis of data for my model. So we have seen this. We'll talk about that in the demo mostly, but this is the data story. This is the data enablement part where we can now bring in through a self-service channel without really worrying about central IT and a lot of these red tapes. We can now actually go, as long as we are deploying this as a part of the production sandbox, having access to production data, we can actually go in, get the data, do data quality checks, bring in the data, and then eventually join the data using a business context and publish the data as a data mart, registered into something like a feature store. So that's the data enablement part. Then we say, once the data enablement is done, how can the new framework help our data engineering, data science, and ML engineering team, right? So this is where the data handoff happens. So it happens in 2.0, where we have a data catalog. As a byproduct of bringing in the data through IDF, we now have a data catalog. A data scientist can now go into the data catalog, and they can search for any data set. They can say, hey, I want to build a product order time series forecasting model. I need some product data. They can go and search for product data to understand where within the central data hub the product data resides. They can eventually also look into the data quality matrices, the profile matrices of the data, to see whether that particular data set is of worth to them or not, right? So through a central shop data experience, data scientists can go into the catalog, which is built as a byproduct of right governed data pipeline, to get access to the data. From there, they can do a little bit of an engineering heavy workload, where through a self-service IDF capability, they can wrangle the data, which means join, validate, transform the data. They can perform certain enrichment of the data, like fixing off certain data attributes. Then they can do a data quality assessment. Again, the data quality assessment can be very specific to the model itself. Then they can do a profiling and statistics of the data. The new capability will come with, like I said, pre-built graphs and matrices, because we have done that integration with 10 different EDA tools. To all this feature importance, correlations, statistics, everything can be done visually. Then we can go in and say, okay, based on my initial analysis, what important features are there, and then they can make a decision whether that yellow box is repeatable or not, right? So they can go back and then again do another round of feature enrichment. So then there is a handoff between 9 and 10 and say, okay, we have gone through the hoops, we have identified the right set of features important, and we have registered these features in our feature set. So now what we can do is, again, through the extended accelerator, we have pre-built templates for segmentation, sampling, algorithm selection, AutoML, and whatnot. And we can start evaluating these model outcomes and see which model makes sense. And then all the bells and whistles we talked about, where the outcome of the model, the metadata of the model can be registered and cataloged. These are pre-built hooks, so that as a data scientist, I'm only concerned about the outcome of the model, but the outcome of the model is automatically saved into something like an ML flow. Similarly, all the experiments, pipeline, schema, the baseline of the schema, everything is saved into a model catalog. Now we also have pre-built, model evaluation matrices, where we automatically start evaluating the matrices and say, okay, this is the right model, this model provides the right amount of outcomes. So we are helping the data scientist evaluate the models, and eventually everything else is saved into a central catalog of models. When you go into the central catalog of models, you can now compare models against each other. So you might have done 50 different experiments on the same data. Experiment number 10 you might have done with XGBoost. Experiment number 25 you might have done with LightGBM. And then you can compare these models, the outcome, the scoring of the models, and decide whether things are looking better, not looking better. So you can eventually come back and retrain your models. So by the end of step number 14, we now know that out of many experiments that we have conducted, which is the right experiment, which experiment is something that we can package. So again, now it goes through a manual approval. We have pre-built scripts to package the models. We have capabilities to promote the model from one environment to another, and then we can actually register all of that with MLflow. Put the model into the new MLflow registry. If needed, retrain the model in a higher environment in a low touch way, and then eventually all the registered model can be tagged, transitioned. It can be used for high availability model serving through containerization, and then the models can be served for doing predictions. Once the model is done, all the model metadata can also be synced up into the central repository like Colibra, and then once that is done, we keep on serving the model, keep on capturing the new baseline, and we can make decisions whether the model is good enough or it needs retraining. So that becomes an end-to-end process, the 3-step process, where we start by enabling the data, then we evaluated the data, and then enable the actual model creation, and then finally we are enabling the model productionization. So that becomes a 3-step journey. Now question is, who do we need, right? Do we need everybody? Can data scientists do everything end to end that we talked about in the last 3 slides? The answer is no. So what do we need, right? So here we are trying to understand who are the right teams, what they need to do, and how they can collaborate with each other. So at the minimum, you need a data engineering team, an ML engineering team, a data science team, MLOps team, business team, and a platform team. So data engineering team can help us answer the right questions, whether the data is available in the production setup, is the data pipelines created, if I'm moving the model into production, is also my data pipeline getting moved into production, because I have to continuously refresh my feature store and all, right? From an ML engineering perspective, we talk about, is the pipeline ready? If the pipeline is hosted and operational, how do we distinguish between training and testing data? How do we know which new baseline data is coming up? How do we enable the feedback loop? How do we have the model matrices and governance set up, right? So all the hooks that we talked about, that's something an ML engineering team can enable. Again, the SDK makes it super easy to incorporate all these hooks. The data science team, while deploying the model, the question is, do we have the data science team available to work with the ML engineering team? So the data science team has already done their work. They're saying, I want to toss over this model to the ML engineering side. Question is, do we have some bandwidth so that it's not just tossing over? There is a smooth transition between the projects, going from a data science team to an ML engineering team. Data science team can also help build some of the use cases, model acceptance testing. The MLOps team then can help set up the CI/CD process. They can help track model availability, model performance, model validations. Similarly, the business team can finally, when the model is deployed, let's say in UAT or in pre-prod, they can validate the model outcome, define and actually enable and enrich some of the test scenarios. And finally, the platform team can actually help to ensure that the right kind of platform setup, security standards, everything else is met, right? So in an actual world, when we go and deploy a model into production, we need to ensure that we have the collaboration between all the right roles. And finally, again, this is something you might have seen. Intention is it's a bird's eye view of what happens from dev to production. You start by building the model. So again, it goes through the coding. You go to the model building part, you write your code, you get your training data. And as an outcome of the model building, you have candidate models. You have one or more models. Then you do a model evaluation and experimentation where each of the model goes through the test data and matrices like model evaluation, and you finally get a chosen model out of the second box. The chosen model is being used for productionization. That's where you move the model through a CI/CD pipeline into a testing environment. You bring in new testing data, you test the code, and you output the model which is tested. The model that is tested is also incorporated back into an application code if needed be. So typically your machine learning models should be a part of some of the business applications. So you can incorporate those models as a part of your application code, and you can do an integration test end to end, and you can eventually observe and monitor the model, the production data. So that becomes a cyclic process of deploying a model from dev to prod. And finally, question is, what do we monitor? What do we evaluate? So when I talk about model monitoring, there are three kinds of monitoring that we have done, right? So till now we talked about bringing in the data, evaluating the model, finding the model that is the best fit, and eventually pushing the right model into production. And now the question is, once we have put the model into production, how can we monitor the model? So there are three kinds of monitoring that you typically need to do. You might have seen this diagram from evidently. So the model uptime is hugely impacted by so many different factors, right? So we do three kinds of model monitoring. One is the system monitoring, data monitoring, and model monitoring. So the system monitoring is about the CPU usage, disk usage, SLAs, whether if I'm deploying the model as a real-time endpoint, is that endpoint sufficient as a training? Is the traffic going into the model, is every single input getting the outcome in their desired SLA or not, right? So all of that is something that we need to evaluate as a system process. Data monitoring, again, same thing, drift in the data, drift in the concept, identifying statistical bias, checking the stability of the data, detecting outliers in the data, detecting the quality and the integrity of the data that is coming in. So all of that is data monitoring. And from a model monitoring, we monitor the model in two ways: during the evaluation phase, during the training phase, and during the prediction phase or during the production phase. So model evaluation during the training phase is all about evaluating the model performance matrices and checking whether these performance matrices are acceptable by business. Checking for model overfitting, checking model performance by segments. So even if you are getting model outcome like, hey, my model is 99% accurate, and accuracy was because we are doing a fraud detection. My model says it is not a fraud, all the time. So if you have 100 use cases, your 99 use cases are successful, right? Because it says no, and the actual outcome is no. But the one use case where you're supposed to detect the fraud, you also said no. Your model accuracy is still 100%. So unless you do a performance by segments, you cannot understand whether your model is evaluating every single segment correctly, or it is throwing up, so the law of averages are catching up, right? Similarly, the ethical bias. So ethical bias is more about checking the outcome of the model during the pre-production and checking whether the outcome is geared towards almost all the different ethical groups, right? And then in production, you talk about model result validation. So whatever the result comes out, can you validate that with business? Can you validate that with the new ground truth? Business KPIs, if the model is acceptable in terms of business KPI. And relationship drift. Are there certain seasonalities? Are there certain correlations between model outcomes and the predicted outcomes and actual outcomes that are drifting, right? So do you need to retrain the model? So all of that together will be a model monitoring capability. So I log in, I'll just jump in and show you how the data enablement part looks like. So the best part of the data enablement part is I'm going to build, it's a self-service portal, right? Which means I'm not dependent. As long as my production playground have access to production data, I as a data scientist or an ML engineer do not really have to rely on central IT to help build these pipelines for me. I can pull in data, I can actually discover the data from a central marketplace. So we have a data marketplace that goes into the data mesh. In that marketplace, you can actually evaluate and look into all the data sets available within the data lake. Once you look into the data in the data lake, it tells you like who are the owners, the data quality reports, the business metadata report. It gives you strong indication about the data. So once you have decided that, okay, this is the data I need, through a self-service capability, you can actually build, prepare, and pre-process the data. So this is the data enablement part where I can go in and I can say, hey, I have these capabilities now. I have business validation for data quality and others, and accessing data assets, default cards for doing data transformation. I have some functional cards that are very useful for data science purposes, like backfilling of missing rows, imputation of null records, creating some pre-processing like one-hot encoding and whatnot, creating rolling aggregates to aggregate your data, perform slowly changing dimensions, lookup, custom requirements, and then we have some ML cards where the final outcome can be registered into a offline feature store, or you can divide the data into train, test, split, or I can detect the drift on the data through some alerting mechanisms, and I can register that as a feature set. So I have a lot of capabilities. So I can say I want to read a few of the data sets, right? So I have, let's say, 3 data sets that I want to read from my data lake. Because I have got access to the data lake, my production playground has access to the data lake, I can provide the location, the name of the data set where I want to get the data from, right? Then I can apply some, simple transformation logic without actually doing anything much. I can do some, backfilling of missing records. Again, we have to write the logic inside. And again, another cool thing I can talk about is, again, something in the works. So we have something called a SQL helper. So you might have been seeing like a lot of this is like, small snippets of SQL that you can provide to create that card. But sometimes you might say, hey, I need to do a join. Let's say I want to do a join between these two. And you do not know, like, hey, writing this join SQL itself is a little tedious process, right? Is there a better way? So we have done also integrations with OpenAI. So now you can go to the SQL helper and say, find top department based on revenue, or something, like just something like that. You can ask the questions, and it's going to give you the SQL, right? So you can copy the SQL, you can put the SQL back into your card, right? So even building some of the SQL queries will become easier. So now, through a very self-service process, without actually focusing a lot on the engineering process, you went to the marketplace, you identified the data sets, you applied transformation, you joined the data. If you need help with SQL, you can get some of the help from SQL. Just to complete the loop, let me do this right. You can write the data back into another location, which will become your final data store, and then you can register the data as a feature store, right? So saying, hey, this is going to be a feature store. I'm going to write this back into a feature store. So this becomes a cycle now. This becomes a process now. And if I go into the preview JSON, it creates all this, everything that you dragged and dropped is created as a config file. So if I download the config file now, and if I schedule the config file using any scheduler of my choice, and if I'm running that scheduler, let's say every night at 6 o'clock, and every night at 6 o'clock is going to go to these 3 data sets, get the data based on the extraction logic I said, is it today's data, delta data, whatever I want. It can apply dedupe, you can do some business transformation like backfilling missing records, apply join, write the data, and then register the new data into the feature store, right? So it becomes a cyclic process. Access to a feature store which has recent data becomes very easy. And the moment when I decide I have to put the model, eventually the final model into production, I also have to think about putting the data pipeline into production. And putting this data pipeline into production is just like putting the config file into production. I don't have to rewrite a single line. So not only I save a lot of effort in building a self-service way of building the access to the data, but now when I'm tossing it over to a data engineering team, my data pipeline is mature. It is production ready, right? So IDF from a self-service possibility, it can help me unify data, do a lot of pre-processing, do a lot of aggregation, prepare the data for machine learning, and finally write the data into a feature store. And that becomes a repeatable and reusable pattern in itself, right? So step one is I go through the hoop, I get the data, I finally save the data, and I use this data for my model training. During the model training, during the EDA phase of my model building, if I find that I need to evaluate my model features more, I come back here. And I can just update the code. I can update the SQL. So this particular pipeline gets refreshed and refined as we are doing exploratory analysis of the data, so that by the time we are ready with the data, this pipeline has become a solid production ready pipeline. What I really want to talk about would be on this SDK. So this is the IDF ML SDK. This SDK has capabilities. We'll talk about the capabilities. And the capabilities are, it comes with a lot of things, right? So for example, we have modules for automated visualizations, what if analysis, scenario analysis, common utilities to connect to your feature store that we just now pointed to get the data integration modules, controllers. We'll talk about a lot of these, right? It comes pre-built with a lot of these bias evaluations. So you can say I can plug in something like evaluate the biasness of my model, right? And it can automatically give you a detailed report of the biasness, or you can log the observability of the model in the data. So all of that will be something we want to talk about. But for now, we want to pause here saying in a 3-step process, data enablement, ML engineering or ML experimentation enablement, ML productionization and enablement. Out of 3 things, data enablement part is what we talked about right now. And in that case, in this part, we think IDF plays a huge part in just enabling access to production grade feature stored data. Thank you again for attending.